coming days. Okay. One of the most kind of incorrectly used techniques in algebra is proportions. Okay, and using what we call cross products. Okay, so I'm going to try to hopefully maybe clean up some of that with you today to make sure that we understand when, where, and why we can use the idea of cross multiplying. You guys have heard that phrase cross multiplying before, right? People want to think that they can cross multiply whenever they see fractions. I want to kind of erase that statement and try to fix that for you in regards to when we're supposed to use this process. Okay? So some key terms here, a proportion. We have to first understand what that is. A proportion is just a type of equation. It's a special type of equation. And it's the equation that says two ratios are equal. Well, ratios are fractions to us, right? So it's just the equation that says one fraction equal to another fraction. Okay? Now, the idea is that the left-hand side of this equation can only be one thing, and that one thing is a fraction. The right-hand side can only be one thing, and that one thing is a fraction. So examples of proportion. We could have something like, x over 3 equals 2 over 6. Okay? That would be a proportion. You have one fraction here equal to one fraction, a ratio equal to a ratio, right? Some specific proportions. Give me a fraction. Let me give me a fraction. 4/8. Okay, I heard 2/5 first. Okay, 2/5. Would you guys agree that 2/5 is the same thing as 4/10? That is a proportion. Whenever you take a fraction, like 4/10, and reduce it down to 2/5, that is saying that we have a proportion. Is that all right? Travis, put your phone away. So if 2/5 is equal to 4/10, that's a proportion. Okay? If we have 1/2 equal to 2/4, is that a proportion? Are these two fractions equal? Yes. What about 1/3 equals 2/3? Is that a proportion? Can I reduce 2/3 down to 1/3? No. Okay. Basically, what we're saying here then, if I have half a pie, that is equivalent to having 2/4 of a pie, right? If I have 2/5 of a pie, that's equivalent to having 4/10 of a pie. It's the same amount of pie. So if I have 1/3 of a pie, is that the same as having 2/3 of a pie? That's different, right? I have different amounts in front of me. So that would not be a proportion.
Is that
1/3.
Oh, crap.
Well, that's fine. We're at 1/8 and then 2/3, and it's still not a proportion.
Oh, right.
So not a proportion. Okay. Now, a key idea here, and this is what will lead us to one of our main principles in this section, is that if I multiply, let's just real quick multiply, look at this one here. Multiply both sides by 10. If I multiply this side by 10, okay, I get those to cancel out, right? And it leaves me 2. What's 2 times 2? 4. And on the right-hand side, I get 40 over 10, or I can just say that those cancel. And that leaves me with 4. Is that a true statement? Yeah, 4 equals 4. Over here, I multiply both sides by 4, right? Okay, so that's going to cancel, leave me 2. So 2 times 1 gives me 2. Over here, those are going to cancel, and leaves me 2. Does 2 equal 2? Yeah. Here, I multiply both sides by 3, right? Does that make sense? I'm looking at multiplying by an LCD here is what I'm doing. If those 3's cancel, that leaves me 1. These 3's cancel, leaves me 2. What kind of statement does that give me? False. And that gives me a false statement. And why? Well, it's because it's not a proportion. If it gives me a truth, if I multiply by an LCD and it gives me a true statement, then I have a proportion. Meaning one of those fractions can turn into the other one, but it's still the same amount. Okay? If it doesn't give me a true statement, then it's not a proportion. Okay? So We'll talk about how that is maybe a little bit of a, or there is a simpler way of maybe realizing whether we have a proportion or not. But that's the logic of it. That's the logic of the next thing that we'll do here in a little bit. Just some specific examples. We saw these back in section 2, 2, 3, 2, 4. If I want to solve this proportion, I want to take these denominators and come up with the LCD. So the LCD in both of these would be 3 and 7 multiplied together would give me 21. So I'm going to multiply this side by 21. And I'll multiply this side by 21. Okay, now if you do that, you're going to get this 21 and that 7 to cancel, right? And what would you be left with? You'd be left with 3. And then 3 times 4 gives you 12, right? I'm multiplying this side by 21. That 21 and that 3 are going to cancel. Leaves you with 7, right? 7 times f would be 7f. Divide both sides by 7. So 12 sevenths is equal to f. And my argument here, guys, is that even though we are learning how to solve proportions, you already have a technique that does that. Okay? And the new technique that we learned today is just a different way or a different perspective of what we just did. And what I mean by that is, let's just kind of do this. Let's rewrite this and say 4 over 7 is equal to f over 3. To get this 12, we multiply both sides by 21, and they cancel, and that's be 3 times 4, right? If I cross multiply, what's that give me?
4 times 3.
4 times 3. It's the same thing that we were doing right there. 4 times 3 gives me 12. If I cross multiply here, what do I get?
I like that.
And that's the same thing I was doing there, right? And I agree. We like that so much better. It's so much more efficient, so much quicker. But what I want you to understand is, why does that work? Why does multiplying cross products work? It's because it is getting us ultimately to be multiplying both sides kind of by an LCD. Okay? Does that make sense? Really what's happening is I'm making this side 7 times bigger, because that's what I did here when I multiplied by an LCD. And I'll make this side 3 times bigger, because that's what I did here when I multiplied by an LCD. And when I do that, that's the equation I generate, and we can solve that. Okay? So, looking at this one, I want to use an LCD again. What would be the LCD here? Be 45. We're trying to figure out what would be that first. If I make 5, and then 10, 15, 20, 25, so it's just increasing, finding multiples of 5. And do the same thing with 9, so 18, then 27, then 36, and then 45. And I keep doing this. I'm looking for the first time that these numbers become the same, right? So then the LCD between 5 and 9 has got to be 45. So I multiply that by 45. Multiply that by 45. Now, when these cancel here, that's going to be 9 times that 2, right? What's 9 times 2? 18. Over here, those are going to cancel and me 5. What's 5 times 8? 5/8. Okay, that's great. That's using LCD. But if I look at this, isn't it much faster to get that LCD by doing that? Well, not the LCD, but the equation. Multiplying those and those. And that will give me 5/8 equals 18 as well. Okay? What I want you to understand, that only works if I have a fraction equal to a fraction. Okay? So here's the rule. So to determine if two ratios are a true proportion, use our cross product idea. And the next statement is that idea. It's cross product. Because if a proportion is of the form A over B equals C over D, where A, B, C, and D are any numbers you want them to be, except for B and D cannot be 0, can never divide by 0, then what we get when we multiply those two there together, A and D, we get that statement right there. and we're going to multiply these two together, B and C, we get that statement there. That is the idea of cross products. That will always, 100% of the time, be true. Okay? So, earlier, in these questions up here, we were trying to, where'd it go? These up here that we wrote down. We were trying to multiply both sides by an LCD to get 4 equals 4 and 2 equals 2, right? Well, if I cross multiply, what's 4 times 5? 20. What's 2 times 10? 20. Is 20 equal 20? So that tells me I got a proportion here. Okay? If I go 1 times 4 and 2 times 2, tells me I've got a proportion. So we're down here. 2 times 10 is 20. Does 20 equal 5 times 4? So yes, this is a proportion, which means this is just an unsimplified version of 2/5. Let's go here. What is that product? Huh? That's 72. So 8 times 9 is 72. 8 times 9. And then 3 times 24 is also 72. 72 equals 72? Yes. So that is a proportion. What about this one? What's 2 times 5? 10. What's 3 times 4? Does 10 equal 12? Nope. That's false. Not a proportion, which means 2/3 as a fraction is different. It's a different amount than 4/5 is as a fraction. Okay. I'm going to. So here's the idea. If I have, I'm going to use these arbitrary values of A, B, C, and D. Okay. When you multiply these two together, we call that product a special name. We call them the extremes. Because I want to be able to talk about, when I say cross product, I'm talking about A, B, and B, C together at once. Well, if I want to talk, it's kind of like if I want to talk about you guys, I talk about you as a class together as just, I say, 6th period, right, or 5th period. If I want to talk about individual people, I got to have names for those individual people in the class, right? Yeah. So when I talk about cross product is A, D, and B, C. If I just want to talk about A, D, I need a name for those. If I want to just talk about B, C, I need a name for those. So these are the names for those individual products. Okay? The extremes, what does it mean if I talk about the temperature is extreme? What does that mean? It's high or low, right? But it's on the end of our thermometer, correct? It'd be at the top of our thermometer or at the bottom of our thermometer. Well, if I rewrite this as, if you read this, just read this to yourself. What's the first thing you say? A. What's the last thing you say? D. Would you agree that I could write this way? We could use the colon idea. Would you agree that A and D are on the outside? They're furthest things apart from one another? And isn't that what our extremes are on a thermometer? They're the furthest things apart from one another, right? So the first and last thing. So the means, if you go back to talking about mean, median, mode, range, those are called central tendencies. If we talk about those things, they mean just kind of locating the middle object. Okay, different ways of talking about the middle. So means refers to middle, extremes refers to the end. Okay, so you're going to hear me say, take the means and multiply them together. Take the extremes and multiply them together. Okay. So we can individually talk about then those products, those separate products. I want to do a couple examples here today, and then we'll finish up and do the other examples tomorrow. Well, let's say I want to solve this proportion. What are you going to do first? 4 times 8. So that's taking the extremes, right? So 4 times 8 gives you 32. And then what are you going to do? 3 times x, and that's your means, right? Can we solve that equation? Divide both sides by 3, right? Okay, so we have 32 thirds is equal to x. Now, in that situation, 32 and 3 don't reduce at all. We leave it alone. Okay, here's the idea behind this. We have just found out what needs to be divided by 8 so that I get the same thing as 4 thirds. And just to prove that to you, 4 thirds is that number right there, right? If I take 32 divided by 3 and divide that then by 8, does it still give me 1.333?
Yeah.
Okay. If you type it as a fraction, it should give you, what is that, 8, 16, 1, 256 over 3. Wait, what am I doing? Oh, I'm sorry. I messed my 8 up. Do it this way. So we know I put 32 over 3 divided by 8 over 1. Can I multiply by the reciprocal here? You guys remember doing that? Fraction divided by fraction? So that 32 and that 8 cancel, give me 4. What's 4 times 1? 4, what's 3 times 1? That give me the 4 thirds right there?
No.
Okay. So we need to have that 32 thirds as my x value. What about this one?
55.
55 equals 6x. So divide both sides by 6. Now some of these will reduce. The 2 that I just chose, that they don't though. Okay? I want to do one more with you, and we'll pick up with this after tomorrow as well. If I come down here, these are more complex, right? These are more complex, but what do I need to do? I need to multiply those, and I need to multiply those, right? So if I do the blue one, it's 5. Now b plus 3. That's how I have to do that, because b plus 3 is now an amount, a quantity, right?
So then would it be like b plus 3? Or 5b plus 3?
It would be, hold on, so that was the blue. Let's do the green now. It would look like that, right?
Yeah.
What does this algebra tell us we have to do?
This should be 5b and then plus.
Good. So I'm at 5b plus 15. So when you take cross products and there's a quantity as one of your products, you have to distribute. Down here would be 4b minus 32. How am I going to solve this? I heard subtract 15. That's fine. So it's going to be 5b equals 4b minus 47, right? Now remember, we want to separate the b's, right? Separate the b's in the constant. So how do I get this to go? Subtract 4b. And this is what we worked on in the last couple sections so that we could generate these equations with proportions and know how to solve these equations that we generate. So we get b equal negative 47. Now let's go to GeoGebra real quick. Or not GeoGebra, Desmond. Sorry.
I thought you said GeoGebra.
And we had what? b minus 8 over 5. And we had b plus 3 over 4. Okay. And now I said b was negative 47, right? Is that the value that makes these two fractions, these two ratios the same? Okay. Any other number that I plug in there would give me something like that, where it gives me two, the evaluation the left-hand side and the right-hand side at different amounts, and they're not equal. Okay. Negative 47 is the one and only one value that I can put there to where I get two equivalent ratios. Okay. Tomorrow we'll continue with some of these harder types of more complex examples. Right now, and here's the thing about mathematics. Right now, we can only take the b minus 8 and the b plus 3 and have both those in the numerator, or have both of them in the denominator. When one is in the numerator and the other one's in the denominator, that gets us into like algebra 2 type stuff. Okay? But when you get to algebra 2 and you start working with those things, they're not going to they're going to remind you that cross products are equal. Okay? And when to use them. They're just going to say, hey, start with this equation, you'll know that the way it looks structured, you cross multiply, and then the equation you get from that will be something different than 5b plus 15 equals 4b minus 32. The idea is that in algebra 1, we learn what cross products are, how we can use them, and then in other other courses, the structures might change the type of equation that's created.
Have a good day.
Thank you, too.